thanks to those that just joined us. My name is Mitchell Lilly, the Executive Director of Communications for CESA Purchasing. We are a statewide Wisconsin cooperative purchasing organization housed within CESA number 2. But we're, like I said, a statewide program. So we support all school districts in Wisconsin with purchasing needs. We have over 80 vendor partners. ELB is one of our partners, which means that because of our cooperative purchasing agreement together, purchasing with ELB is much smoother than it might be with others, and they have great pricing and some value benefits to the contract as well that they may mention here. But if you have any questions regarding purchasing, school purchasing, cooperative purchasing, vendor contracts, we have over 80 partners, so feel free to shoot me an email or reach out via cesapurchasing.org.
Great. Thank you very much, Mitchell. Appreciate that. My name is Andy Byer. I'm the VP of Sales for ELB, and I wanted to do a very brief overview and leave the majority of this meeting to really discuss the engineer mindset and how the STEM solutions that our premier partner, Boxlight Mimeo, we've worked very closely with, we'll show you how that's really being implemented into schools around the country and around the world. So with that, I'm going to share my screen very quickly and give you just a little overview about ELB. And we're a 35-year-old company and one of the world's largest audio-visual companies really in this space. Our special area of focus is K-12. We have offices throughout the U.S. In Bolingbrook, Illinois, that covers the Midwest, the Wisconsin, Illinois area. 3 locations out in California, 1 up in Seattle, 1 down in the Dallas, Texas area. We also have a large consulting, engineering, and design project management team that helps with the installation team to really deliver a full comprehensive solution. And, you know, we work with thousands of schools across this country to implement those programs. Most of our technology is from the Boxlight Mimeo team because they have a wide range of technology for the classroom, a whole digital ecosystem. But we also have a lot of other things that we do around training and around making sure and ensuring that the technology is being used properly in the classroom. Just a little overview of our overall solutions. Today, we're really going to talk about the STEM technology. We do offer anything from Chromebooks and PCs to all types of furniture for learning spaces, from STEM labs to media centers to the classroom to administrative offices, as well as a whole integrated solution for audio-visual systems. And one of the things that we like so much about our partnership with Boxlight Mimeo is that they have pulled together a number of their products where they all are integrated into their interactive flat panel, the Mimeo Pro 4, with Front Row, which is now a Boxlight company for classroom audio and alert solutions and systems, from bell systems to paging systems to emergency notifications, and also the whole Mimeo STEM solution and EOS professional development. We're going to talk more about the STEM solutions and the Robo 3D printing and also the robotics and the lab discs. One of the things about developing an engineering mindset is understanding all of this. And one of the things that we really like about what Boxlight Mimeo has done is created a whole curriculum around this. There are a lot of folks with 3D printers out in the marketplace that really don't use them in the capacity they should in really project-based learning. What you'll hear today, I think, and what Braydon's going to share is how some schools are using this and this technology not only in STEM labs but throughout their curriculum in history lessons and math lessons and throughout their whole school. So with that, I'd like to introduce Braydon Moreno. He is the founder of Robo 3D STEM Solutions, definitely a leader in the space. his company that he founded was acquired by Boxlight a few years ago, and that's giving him broader reach into the marketplace. And so we're very happy that he's able to share some of his success stories and what some schools are doing, and see how it may be able to help you in what you're doing in your schools. Braydon?
All right. Thank you, Andy, for the intro here. I'm going to dive into some stuff. Can everyone hear me? Are we good? Yes, thumbs up. Hopefully. Okay. Yeah, so I'm going to give you a little bit of background on me, and then we'll talk a little bit about STEM in general, but really want to focus on how to develop an engineering mindset in K-12 with 3D printing specifically. I know that was the title of what we're going to chat about. So we're going to dive into this, and then hopefully I'll have enough time if you have any questions, things like that. Happy to answer any of those after we go through some of this stuff. So first and foremost, I know Andy did a little bit of an intro on me. My name is Braydon. I am at heart a 3D printer nerd. So I've been doing 3D printing for almost a decade now. One of the founders of Robo 3D, which is our 3D printer that we have under the Boxlight STEM umbrella, which we're going to talk about here in a second. And then, now since we got acquired by Boxlight, I'm the director of STEM. So deal with multiple different STEM products, curriculum, the way they integrate into schools and districts, all that stuff. So, I've been involved in the classroom for quite a while now with this different technology, and have really helped a lot of these schools and districts, implement it successfully. Briefly, before I dive into the engineering mindset stuff, I do want to just give you a quick overview of what we have, just so you kind of understand what our STEM solution consists of. First and foremost, 3D printing, which we're going to talk about today, and I'll share some stories and things like that. So we have the 3D printing solution called Robo 3D. That picture right there is our smaller one. We also have a bigger 3D printer, but they are both built for classrooms. So fully enclosed, safe, easy to use, lots of bells and whistles. And as I'm going to mention here in a little bit, we have a fully integrated curriculum that comes with them as well. So 3D printer is one of the solutions. Lab disk is another one of our solutions. So this is, I call it a portable science lab. It's about the size of a smoke detector, fits in your hand, and it has up to 15 built-in sensors, okay? So all those little buttons that you see around the outer edge are all correlated with calibrated built-in sensors. So you can do things like distance, decibel levels, barometric pressure, voltage, pH, all this stuff with one simple lab device. Okay, so that's the lab disk. And then lastly, we have the MyBot, which is our education robotics product. We do have a new robotics product coming out that's going to be a little bit different than this one, but the key with our robotics solution is to provide coding challenges from picture to block to Python. Okay, we're all about student progression. How do we get students into doing true Python coding as quick as possible? So we have a lot of integrations in our coding interface to allow you to kind of do block and Python side by side and things like that. So that's our robotics solution. And one thing about all three of these solutions is they're wrapped around curriculum, okay? We're talking NGSS, standards-driven curriculum, state as well. So 3 products, 1 curriculum platform, hundreds of standards-driven lessons, and they come as a complete program. So obviously hardware, training and certification, curriculum access and support, okay? So want to jump into the topic of today, which is 3D printing and developing the engineering mindset. And I really just taking it back to something we've been dealing with for the past couple of years, which is the pandemic, right? And, when the pandemic first started, there was this massive shortage of PPE equipment I'm sure you're all familiar with, where hospitals and clinics were running out of them. But really, 3D printing and the power of the engineering mindset came to the forefront and was able to create 3D printing solutions to this problem and donate them and share them with the world. So we had tons of just users around the world that were coming up with different designs for personal protective equipment, sharing them with the world. People that had 3D printers at home were printing them and donating them. And it was just a really cool time to see the engineering mindset in action in the real world. So just wanted to share that. We also were able to make and donate thousands of masks and things like that. So it was just a really cool time. And once again, this is just an ode to what, engineering mindset can provide when implemented in something like a school program. Okay. Briefly talking about what is STEM. I know we think of STEM or know STEM as an acronym, right? Science, technology, engineering, and math. Most people talk about it as that, but really the way that I look at it, and I try and simplify things as much as possible when I'm talking to people, is I think of it as a way to use technology. So let's take 3D printing, for example. How do we use 3D printing technology? And how do we use it to teach the subjects we're already teaching, right? How do we use 3D printing to teach science? How do we use it to teach math? How do we use it to teach social studies, language arts? And naturally develop in our students an engineering mindset, okay? So you really can weave this technology first into core instruction and then develop an engineering mindset through, curriculum or through different types of techniques and strategies. So I'll talk a little bit about that, but hopefully that makes sense. And that's really kind of the ethos of the way we have our 3D printing program, is really make it simple, just allow teachers to print and teach, and then kind of weave in design thinking and project-based learning into that. Now the engineering mindset, just briefly going over that. Engineering, obviously applying science, math, and practical knowledge to solve problems. And really the mindset is the ideas and attitudes with which a person approaches a situation. Now, some people think engineering mindset is what engineers are equipped with, but really engineering mindset can apply to everything, right? It's just a way of thinking, a way of processing, a procedure for actually accomplishing a task. So it's something that it doesn't have to be focused on pushing students into engineering careers. It's just a way they look at the world, right? So I think this is beneficial regardless if they go in that path, right? They go STEM pathway, engineering pathway, it's really just going to be valuable for them in life in general. And so this is something that a teacher actually put into a classroom that I wanted to share with you all, which was the classroom mission statement. And this was kind of centered around the engineering mindset, which is why I'm sharing it. But this was actually in a classroom that I visited, and it was on the wall. And it said, "We are engineers who build, design, work together, are a team, never give up, care for the environment, are imaginative, problem solve, use tools, and keep trying." And I just thought that was a really cool, I don't know if you want a screenshot or anything like that, but I thought that was a really cool way to just make that top of mind for these students that are in the classroom, right? Get them excited about engineering and solving problems and going through a process of solving problems and doing it for a reason, right? Caring for the environment, caring for the world, right? So just something cool, wanted to share that with you. And then some of the cores of the engineering mindset, right? Realizing that there's no one solution, okay? Things can be solved in multiple different ways. Take 3D printing, for example. Take that example I said with the pandemic, right? There was tons of different solutions that came to the forefront. So there's no one solution. Thinking about the stakeholders for the problem is really important. Like, who are the people that are going to be benefiting from what we're designing or problem we're solving, whatever it may be. And then being okay with failing, right? I think that's a big part of it. We talk about failing forward in the engineering mindset or the design thinking process. So I think that is a perfectly comfortable way to progress in your knowledge, your learning, and in your engineering mindset approach.
Braydon, are you sharing your screen? Because we're not seeing it. So
yes, I am sure. Have you guys not been able to see?
We have not, no. So maybe if you just want to go back and just show what you, sorry about that, but I know you're trying to get a lot in, and
yeah, I've been.
Yeah.
Okay. Well, I've been sharing this whole time. Though I thought.
No, that's why. I'm glad.
Okay.
So there you go. Okay.
Yeah. All right. Well, I don't know if I'm gonna be able to go all the way back because we don't have a ton of time here, but now you can see the three things that I was talking about there.
Braydon, can you just maybe share your PowerPoint after the fact?
Yes.
That way you don't have to worry about coming back.
Yep. I can share my PowerPoint.
Thank you.
Yep. No worries. Sorry about that, everyone. So once again, just talking about these cores to the engineering mindset, just now that you can see it, hopefully that makes sense there. If I do really want to show you this slide because I think this is really important, talking about science, technology, engineering, math, and how we sort of approach using technology like 3D printing in core subjects and to develop that engineering mindset. So just hopefully that's top of mind as we kind of progress in this conversation, the way you think about STEM technology being implemented in your school, in your districts, things like that. Now, jumping forward to the principles of the engineering process or the engineering mindset, right? You can see a whole bunch of different types of principles, right? Obviously, being able to consider real world problems, to envision multiple solutions, right? There's no one way to do this. Failing forward, persistency, and learning from failure. I think the most important one, well, for me, and what we talk about with 3D printing and how we develop an engineering mindset, is using a systematic engineering design process, okay? So what is an engineering design process, right? This is a simple one. This is done, I mean, people have put a design process or design thinking approach in multiple different ways, okay? So you can get even more simple than this. You could just do maybe 4 of these if you're dealing with younger students, but this is kind of a little bit more of a complex one. So obviously asking, right, identify the needs and constraints, who are the stakeholders in it, asking what type of things we need to solve, whatnot, researching, right, figuring out what do these people want if we're designing a solution for someone or a group or an organization, imagining possible solutions, planning, creating a prototype, and then testing it, right? So we create that prototype part using 3D modeling and using 3D printing to actually physically create it, okay? After you tested that prototype, this is the part where, there's most likely, I doubt, when you're doing design thinking or when you're, trying to incorporate this engineering mindset, that you're going to come up with the perfect solution the first time around. So failing forward is a perfectly comfortable way to approach this, okay? We want students failing, it's fine. But then they can improve and go back through this process and develop their next prototype, okay? Is there any questions in the chat box on that stuff? I didn't know. If there is any questions, please type in the chat box. Regardless if it has to do with engineering mindset, if it has to do with 3D printing, I'm happy to answer those as well. So I've been in this space a long time, so I can more than happily help you all with how to implement that technology. I can't see it, so if there is anything, will you stop me, Andy, or someone from the ELB team?
Yes, I will, Braydon. I'm monitoring it.
Thank you so much. All right, so once again, this is for those learners that learn better with 1, 2, 3, 4s. So engineering mindset process, ask questions and research is a really simple one. Imagine possibilities and discuss. Have students collaborate, plan, and create a solution, and then test and improve, okay? So just a simple way of looking at it, a simple way for students to kind of figure out the approach that they're going to take to develop this process. And I promise you, if they're going through this process over and over again, when they're doing designing in class or when they're approaching other problems in class, whether it's a project-based learning lesson or something along those lines, this is going to help them in multiple avenues in life, right? Not just what they're doing in the classroom, but also things that they have to approach outside of the classroom, okay? This process is super beneficial. I've seen students go through this in the real world, and it's really cool once it's kind of become habitual in their everyday life, okay? Now, I do want to talk about a couple of stories here. I know we have a stop, I think, in about 9 minutes or so, but obviously I'll be on, I can answer questions and things like that. But there is a few stories of teachers that have gone through, I mentioned in that first slide, our curriculum platform called mystemkits.com. And I can jump over and show you that here in a second, but these are some teachers that have gone through that curriculum, got comfortable using 3D printing technology, and then were able to kind of go through and utilize this engineering mindset or design thinking process to develop or solve real world problems, okay? So the first example is Shelly Emsley. I talk about this story a lot. The ELB team probably heard me a dozen times at least. Shelly is a teacher in a small town in Montana. It's called Big Fork. It's about, I don't know, less than 5,000 people. She's a 5th grade teacher and went through, used our 3D printers, got comfortable with our curriculum. And really our curriculum, once again, was centered around just allowing you to use the 3D printer to create manipulatives and things like that that help you, revamp the learning experience in the classroom. But she was able to do that and then start going into doing design challenges that we have in that curriculum platform. And while she was at home one night watching a documentary online, she saw that coral reef was dying around the world in like massive numbers. And she said, what if I can go back, use this design thinking approach or this engineering mindset process and allow our students to try and solve this problem? So they first started out just designing coral that they could actually 3D print in different colors and build a coral reef wall. And that was a way for her to sort of get the students to buy into what they were doing, like love the ocean, realize its benefits, learn about coral, all that stuff. And then take it a step further, and she actually started connecting with marine biologists and coral reef scientists. And they actually started making structures out of a biodegradable 3D printing material that could be planted in the ocean that inhibit coral growth, okay? So they look similar to this. This was kind of like their first prototype of it, but these are actual structures. It's made with an algae-based 3D printing material. It's put together in pieces and actually can be planted in the ocean, and coral will grow and live on it, and it will degrade over time and leave that new coral structure. So this is the type of cool stuff that can happen, once again, when things like 3D printing are implemented into a classroom. Even if in its simplest format, just printing manipulatives, doing hands-on activities with the students, and then kind of getting into doing design and engineering. You can create really cool things like this, okay? Another teacher in Massachusetts, similar approach, went through doing curriculum, building things with a 3D printer, and then had this idea to create a website called the Design Problem Bank, okay? So this was a website. Actually, it's really cool because she used a thing called Wix, if you're familiar, or Weebly, which is a free website builder. And they built this website where the community, the parents, things like that can go on there and they could submit ideas for things that the students can actually design. So it's really simple. You go on there. She just made all these little bubbles. If you click on one of the bubbles, like post a problem, or she had one that was post an idea, you could click that. It opens up a little box, like sort of a contact box. You could type in your idea, and then it would create that problem in their problem bank. And then she would assign students to solve this problem. So a really easy way, once again, someone's submitting the idea, the community is buying in, the community is sort of the stakeholder, right? And so when the students are going through the engineering mindset or design thinking process, they have to consider that stakeholder. What do they want? Things like that. And they're designing a solution to their problem or their idea, okay? So just wanted to share those two examples. There's one last example that I think is really cool, and that's in a school in California, Calavera Middle School. They've used the engineering mindset and design thinking process. I use those two interchangeably because the design thinking is part of that engineering mindset. They actually partnered with an organization called Enable, and Enable connects you with students around the world in need of prosthetics, or kids around the world in need of prosthetics. And so these students have created an after-school program where they're connecting with kids around the world who need prosthetics, and they're custom building prosthetics for these kids using 3D printing. So they're taking measurements, they're designing them based on whatever the interests of that or the needs of that kid is. And it's just created this really cool culture at that school. And they've made, I think now, over 40 or so different prosthetics for kids around the world. So yeah, they go through that entire design thinking process, consider what type of things they have to incorporate into design, and then also what kind of ways they want to customize it for the actual person they're making it for. So that's really cool. Lastly, just a couple things. My engineering mindset into core learning. Once again, I can't stress that enough. I can pop over here with a couple minutes and kind of show you how that works in our curriculum if you want to see that. But you really will start, I think classrooms will start naturally developing that mindset when you incorporate technology like a 3D printer in the classroom, right? You're making stuff, you're creating things, and then students are naturally going to be like, well, I want to build something. I want to create my own thing. I was just speaking at a conference, and at the end of it, I asked all the teachers that were in that classroom, I said, what are some ways that you've used 3D printer in the classroom? And this lady raised her hand, and she said, the other day, I had a student that came up to me after class, and he had a lunch. He always carries this lunch pail with him, and he loves Ritz crackers, and he had Ritz crackers in this lunch pail. But every time he brought it to school, all the other stuff in his lunch pail would smash the Ritz crackers. And so what he was asking the teacher was, can I design something and 3D print it that will hold my Ritz Crackers holder or Ritz Crackers in my lunch pail perfectly? And, you know, most people, and you might even see that or hear that and think that's a cute story and whatnot. And I think everyone in that space sort of, you know, people were laughing or saying like, oh, that's so cool. But what I really saw was this student naturally developed an engineering mindset, right? They had a problem. They decided they wanted to come up with a solution because they were equipped with these skills in the classroom. And they wanted to go through that process. Like, what do I need to consider? How do I design it? I want to make a prototype. I want to test it. And it was just a really cool way to see it in such a kind of a minimal example, but that was really powerful to me. So once again, that's something we want students to have, you know, time and time again, if we can create that, you know, kind of experience for them in the classroom. So tie it into core learning, make it useful to a problem today, easy to understand for the group of students you're teaching, right? Have them buy into it. And a lot of what we do with our design challenges in our curriculum is tell a story, right? So create some type of story that the students can buy into and get them excited about, you know, designing or creating something or solving a problem for a specific purpose. Create a story for the why, sort of goes hand in hand with the last one. Be okay with it being an uncomfortable process. I know, you know, incorporating this type of design thinking into a classroom or getting students to create and build things on with a 3D printer can be a slow process, but it will be really fun, and you'll see a lot of students come to life with that process. And then just the last thing, a reminder, kids are smart. Let them do a lot of that work. They'll be able to solve problems, use the 3D printer, and have a lot of fun with it. So feel free to lean on them as much as you can in that process. Where can the engineering process fit in? Obviously, the classroom, right? Once again, with our curriculum, you can use a 3D printer to create manipulatives, do hands-on activities, and then sort of add in design on top of that. So that can be done in the classroom across a lot of core subjects, you know, science, math, social studies, things like that. Library, right? I think we're revamping libraries or media centers and turning them into kind of spaces where students can go in and create and build and do things. And then makerspaces, right, are an obvious one, right? Focus on design, focus on prototyping, something like Annie did when I was talking about the design problem bank. So have that space be somewhere where a student can go in and actually create either their own idea, or you develop a challenge when they go in that space where they can actually go through this process and design their own things. Lastly, just a couple of resources I wanted to share with you. If you haven't heard of this YouTube channel, I know it's not a massive YouTube channel, but there's some really, really great videos. So I would highly recommend checking that out. And then also this book I read, which is fantastic. So once again, a lot about engineering mindset, design thinking process, and all that. So check those out. Really good resource. And then also mystemkits.com. I know we're at the end of the time here, but I do want to jump over and show you that, because those of you that are on here that may be interested in 3D printing, this MyStemKits is really going to be a launch pad to be able to use 3D printing in any classroom environment. So let me jump over real quick. Hopefully you guys were able to see my screen the rest of that time. So I know I lost you in the first start here, but I will share that. So the way, for those of you that are on here that are like, hey, I have a 3D printer or I'm interested in 3D printing, the cool thing about MyStemKits is when you get our 3D printers, you also get access to this platform. And you can go in here and you just click printer management, and it allows you to link your 3D printer into the curriculum platform. Okay, there's a code on our device. You click register printer, you type that code in, and it pops up here. Voila. Once you've linked your printer into the platform, you just go into browse kits, and this is where we have hundreds of lessons and activities and things that you can do with a 3D printer. So you can filter by grade level, you can filter by subject, you can search in the search bar by a topic, by a subject, by a standard, and you can find pre-built kits, okay? Now these kits have a couple of different things in them. If I click into one of these kits, like the Catapult one, which is one of our kind of more popular kits, the kits have a video at the top. So for the educators that are out there, it'll help them kind of figure out what they can do with this kit. So video will populate right here at some point once it loads. If I scroll down, we have tons of different lesson plans. Now, some of these kits have lesson plans across, multiple different grade levels. Some are a little more limited, but that's why you use the filtering to find, the specific grade levels you're looking for. So lesson plans down here. And then we have 3D models. And all you do if you want to print these models is just click print, choose your printer, and it's going to send that catapult directly to the 3D printer. So once again, you can kind of get this technology into a classroom space, start creating things, use those created items to do different projects or different hands-on activities. And then when you feel comfortable, you can then go up. You can see that we have design challenges in a lot of kits as well. So you can go up and then weave in design and engineering, okay? Or the engineering mindset process. So start with basic, print manipulatives, do hands-on activities, and then say, okay, students, you're going to design your own catapult now. And then go through the process of doing your design challenges to kind of implement that. Once you do that, you can take it wherever you want to go in terms of design or engineering, things like that. So you can just use this as a launch pad, or obviously you can just go straight into our design challenges and use any of these that we have within here. So it's a really cool platform. Once again, it comes with our 3D printing hardware. So if you're looking for that type of technology, we have a really good solution that includes the hardware, the training, and the curriculum at your fingertips. So is there any questions that came in? I'll share my contact here, obviously. So let me do that.
Yep. And there were no other questions that came in on the chat. There may be some here. And this is Andy speaking. I did put in the chat my email address. So if you would like a personal demo or more information, just reach out to me or Braydon, and we will follow up and get that set up for you. Okay.
Yes. And I put my info in here as well. So yeah, just reach out if you have any questions. There's a lot to unpack with developing an engineering mindset, doing 3D printing in classrooms. It's tough to unpack it all in a session this short, but hopefully you got kind of a little bit of an idea, some stories of how others have done it. And then, like I said, if we want to follow up and go through this more in depth, or if you want to see the curriculum or anything like that, let me know.
Mm-hmm. And the last thing, we do have 2 local resources for you in the Wisconsin area, both Kurt and JM, who are on the webinar here. So we'll put their contact information in as well. And JM, do you want to add anything? Oh, you're on.
Oh, yes. Nothing to add,
Okay.
Andy. I'd be just providing my contact details here, and also I'll be giving a call right after this meeting, those who attended that I have invited. Mm-hmm.
Okay, very good. Yeah, there's so much more here, and we kind of rushed through it, but we just really wanted to introduce this whole engineering mindset, what Boxlight at Mimeo is doing with this. And the other thing I think that Braydon didn't mention, outside of the Robo 3Ds, if you do have any 3D printers in your school or in your district, the MyStem Kits software will work with that as well. So it can enhance the value of the investment that you've already made in your hardware, and bring a whole curriculum platform to your school district.
Yeah, Andy, thanks for saying that. I did forget that. Yeah, it works with over 75 different brands. So if you have 3D printers sort of scattered around and you're looking for a way to kind of get them up and running and utilize with curriculum, my STEM kits could be a solution for that.
Okay. Any other questions? Okay, Mitchell, would you like to close out?
I would just say thanks to everyone for joining. I know that Megan's recording this as well, so maybe we can send out the recording to those that may have signed up and missed it, or if anyone had to jump off early. But thanks for joining us.
Thank you, everybody.
All right, thank you, everyone. Appreciate it.
Thanks, Braydon.